Hey guys, it's Ryan, and in this video we're going to look at a set of challenging problems that have to do with pain, temperature, and touch sensation. And we have a set of 4 axons and this very complicated looking data associated with each one. And we'll try to boil this down, simplify it, and use information from these data points to solve these 4 questions down here. So let's get started with the first one. The threshold stimulus for which neuron was below 30 degrees Celsius? So if you'll remember back to action potentials, the threshold was the minimum depolarization required to activate an action potential. So similarly here, the threshold stimulus would be the minimum, in this case, temperature to activate an action potential. So all we have to do for this question is look at the thermal stimulation data and see what's the minimum temperature required to start an action potential. So in A, we don't see any action potentials at all due to thermal stimulation. B, we see the first one at around 45. Looks like the same thing for D. And then C, we have action potentials beginning at 30 degrees, which is exactly what we were hoping for. So that means the answer for this one would be neuron C. Now the next one's a little bit more tricky. The conduction velocity is greatest for which neuron? And you'll see right off the bat, we don't have any data that tells us about conduction velocity at all. So what is conduction velocity determined by? It's determined by two things: the myelination pattern and the diameter of the axons. And luckily we know something about different nerve fibers. So we know about A alpha and A beta fibers and A delta and C fibers. And we know that the first two have to do with touch reception, and they're fast conducting fibers. Whereas these two have to do with pain and temperature, and they're slowly conducting fibers. And with this information, we can determine which of these neurons will have the fastest conduction velocity. So we'll know we'll be looking for something that's representative of an A alpha or A beta fiber. So let's start with neuron A here. We have action potentials due to mechanical stimulation, and there are 4 categories here: innocuous brushing, which just means a very light touch, light pressure, and then light pinch and hard pinch, which are probably maybe slightly painful. So the first thing we notice is that there seems to be a high frequency of action potentials, which will eventually translate to a pretty serious central nervous system response. Because remember, frequency that's how the peripheral nervous system communicates to the central nervous system. And it seems like there's quite a bit of touch sensation here. So this is a pretty good sign that this is probably one of the A alpha, A beta fibers. So this is a good sign. This is a good sign that this is a fast conducting neuron. We also have some pain stimulation, but this seems to be the dominant stimulus. So that's pretty good. That looks like a pretty good answer. Now for B, there's actually no mechanical stimulation whatsoever and only thermal stimulation. So that means this has to be either an A delta or a C fiber, because it's only responsive to temperature. So this means this is going to be a slow neuron. And the same thing for C, rather. There's no action potentials to mechanical stimulation, and it's only thermal. And then for D, we do have some mechanical stimulation action potentials, but this time it's only in the areas we'd associate with pain. So now we have nothing for touch and just pain and temperature. So that's just classic of an alpha, A, delta, or a C fiber. So that means with all that information, we know that B, C, and D are most likely slow conducting fibers, and that leaves A as the only viable option for this question. All right, great. So let's move on to the next one. Neurons in the dorsal column nuclei in the brainstem receive synapses from which of these afferent neurons? So dorsal column is a huge hint that we're talking about the dorsal column medial lemniscus pathway. And that has to do with mechanoreception from the body. So if we're talking about first order afferent neurons bringing in this fine touch, vibration, proprioception from the body, we're looking for something that only has those stimuli. And so, again, similar to the last question, we shouldn't be looking at any thermal stimulation because we're talking strictly about mechanoreception for this problem. So that automatically eliminates B, C, and D. And so again, we're just left with A. So A would be the answer for this one as well. And then if we move to the last one, it's a similar question, except this time it's asking about the spinal trigeminal nucleus, which should trigger in our minds that now we're talking about a pathway bringing pain and temperature from the face. So now we're going to be looking at which of these neurons has stimulation or reacts to stimulation for pain and or temperature. And so this time, A is going to be ruled out because we don't have any temperature stimulus. But B, C, and D are going to be pretty good options for this question. So in this case, if this was an exam, we'd put E for this one because B, C, and D are good options for nociception and thermoception. All right, great. So I hope this video is helpful in figuring out these challenging problems, and I'll see you all next time.